Hi guys, welcome to Piece of Code and welcome to this lecture. So in this particular lecture we are going to see declaring and initializing variables, declaring multiple variables, identifiers, local variables and instance and class variables. Okay, so we have seen some variables already, right? So a variable is just a name for a piece of memory that stores data, simple as that, kind of a temporary location to store some data. So when you declare a variable, you need to state the variable type along with giving it a name. For example, let's see what do I mean. Okay, so let me go over here and click create a new class, and we are going to name this class as variables, right? And we need the public static void main, right? As we have seen numerous times. So basically string, you specify the type string, for example zoo name or something like int number animals or something like that, simple as that, right? This is how we declare the variables. Now that we've declared a variable, right, we need to give it a value. This is called initializing a variable. Okay, to initialize a variable, right, we just need to type the variable name followed by an equal sign, and then we just specify the value. For example, zoo name equals to, for example, Nandankanan or something like that, right? And for example, number of animals equals to 200 or something like that. So basically this is one type of doing it, and another type, often we need the case to initialize and declare the variable in one line. We can also do that. For example, int x equals to 10 or something like that. It is also possible. Now all these things are really easy, or you can just think that it is a piece of cake, but in the exam they will try to test you. So let us see some of the concepts which can confuse you, and one of the concept is basically declaring multiple variables. So you can declare and initialize multiple variables in the same statement. Okay, how many variables do you think are declared in this particular example that I'm going to give you? Try to figure it out. For example, I'm just going to say string s1 and s2, right? I'm going to do this, and string s3 equals to, for example, yes, and s4 equals to, for example, no. Okay, so 4 string variables in this case, right? If you guessed 4, then you are very correct. So 4 string variables were declared, s1, s2, s3 and s4. You can declare many variables in the same declaration, right, as long as they are of the same type. Very important to remember. You can also initialize any or all of those values in line. In line means in the same line. Okay, so basically in the previous example that we saw over here, right, we initialized 2 variables s3 and s4. The other 2 variables remained declared, but it didn't get initialized in this case. So we declared total 4 variables. Out of those we initialized 2, and the rest to remain uninitialized. Now this is where it gets tricky actually. Pay attention to the tricky things. The exam will attempt to trick you. Again, let's see how many variables do you think are declared and initialized in this code. Let's see an example. So int i1, so example i2, i3, let's see, equals to 0, something like that. Now as you should expect, right, 3 variables are declared. That is pretty simple to understand. Whenever you see this kind of code, and in the declaration perspective, if it is of the same type, then the number of identifiers that you see corresponds to the number of variables declared, right? So 3 variables were declared in this case, i1, i2 and i3. However, only one of those values were initialized, which is i3. The other 2 remain declared but not yet initialized, and that's the trick, right? So each snippet separated by a comma is a little declaration of its own, in simple words. The initialization of i3 only applies to i3. It doesn't have to do anything with i1 or i2. So it doesn't have to do anything with these two things. Despite being in the same statement, every kind of variable is independent of each other. So another way the exam will try to trick you is that it will try to do int num and, for example, string value. Now this is where it gets a little bit tricky. Here it does not compile, or something like that. So the code doesn't compile because it tries to declare multiple variables of different types in the same statement. Okay. The shortcut to declare multiple variables in the same statement only works when they share a common type, like we did in the previous examples right over here. Alright, so make sure you are paying attention to all these things because these are really important. Now, moving forward, make sure you understand this. Alright, see if you can figure out which of the following are legal declarations. Legal, valid and compiles are all synonyms. Okay, so basically they will ask you in the exam, right, okay, which of the things are legal declarations, which of the things are illegal declarations. Okay, let us test it out. If you can answer which of those things are legal and which are not legal. So let me just do it in the notepad, otherwise you will be able to see if it compiles or not. So the first one, let's try boolean b1. Try to answer it on your own. Okay, b2, right? Then I'll copy all these things to the ID, then we will check. String s1 equals to, for example, 1 and s2. Then let's say double d1 double d2. Okay, int i1, for example, i1, int i2, and let's say, for example, int i3, and for example i4. So we have here boolean b1 b2, string s1 equals to 1, and then we have an s2, then this statement, then this statement, and at the end this statement. Try to figure out which of these are, you can pause the video and figure out which of these are legal or valid or compiles, or which of these are illegal. Okay, alright guys, so let us copy all these things back to our ID and let's check your answers. Alright, let's double check if you got it right or not. Okay, so let me just copy these things and back to my ID, paste it over here. Let me just comment, just a minute, let me just comment all these things out so that will not be a problem, so that any kind of conflict doesn't occur. Alright, so we are ready. So if you see over here, the first statement is completely legal. Alright, it declares two variables without initializing them. Okay, that is fine. The second statement is also legal. It declares two variables and initializes only one of them. Okay, over here. The third statement is not legal. Alright, Java does not allow you to declare two different types in the same statement. But wait a minute, variables d1 and d2, if you see over here, are of the same type. They are both of type double. Although that's true, right? But still it isn't allowed. It is not allowed. If you want to declare multiple variables in the same statement, you must share the same type declaration and not repeat. For example, if you want to do the same type declaration, do it like this, but do not repeat the data type again. If you do it, then Java will consider that this is a different kind of a type, and it will throw a compiler error. If you would have done it like double d1 comma d2, then it would have compiled. The fourth statement is also completely legal. Although int does appear twice in this particular scenario, each one is in a separate statement. A semicolon separate statement in the Java. Alright, so that is one of the things. It just so happens that there are two completely different statements on the same line. Okay, that's the thing. The fifth statement is not legal. Again, we have two different statements in the same line and it is not legal. And if you see over here, we haven't specified the data type for it. If you have specified like int over here, then this will be one statement, this will be another statement, and it would have compiled. Alright, So this is how they will try to trick you. And basically this declaration that you see in the last line, and can be a little bit tricky because you would assume that this semicolon is kind of a comma, and then you will get it wrong. All right, so yeah, that's how basically questions may come in the exam. So make sure you guys are really paying attention to everything. Okay, I'm just commenting these things out because we are going to write more code. I don't want these to throw any compiler errors. Okay. All right, so let's go back to the topics, and the second thing that I want to discuss today is identifiers. So basically it probably comes as no surprise that Java has a precise rules over identifier names. Luckily, the same rules for identifiers apply to anything you are free to name, including variables, methods, classes, and fields. Okay. Now let us see some rules regarding identifiers. Whenever you are naming an identifier, let us see what are the rules regarding it. Okay, let me just go back over here. Okay. So the rules goes like this: the name must begin with a letter or the symbol dollar or underscore. Okay. Subsequent characters may also be numbers. You cannot use the same name as a Java reserved keyword. Okay, so that is a different scenario. As you might imagine, a reserved word is a keyword that Java has reserved so that you are not allowed to use it. Okay, remember that Java is case sensitive. All right, so you can use versions of the keywords that only differ in the case, but it is a good practice if you don't do it like that. So don't worry, you won't need to memorize the full list of reserved keywords. The exam will only ask you about the ones you already learned, such as class, if, else, for, or something like that. Okay, but there is a list. If you want to know the list of keywords that is present in Java, you can just Google it out, and if you want to remember all of those, you can remember, but basically the exam will not test you in that depth for keywords. Okay. All right, so let us do one thing. Let us try out some identifier questions that may come in the exam, and the basically the exam may test you on those things. Okay, so let us go back and see some valid identifiers and some invalid identifiers. Okay, so if the identifier names comes like this, so let's say for example OK identifier, or for example dollar OK identifier, or for example underscore also OK, for example DENTIF, something like that, underscore still okay, something like that, something gibberish kind of things. Okay, but not good, or something like that, and then a dollar. So if I just copy all these things and go back to my IDE and paste it over here and just associate it with, for example, an int and here also let me go and just paste it, and like this, like. So if you see, all of these things are valid. They may seem invalid, but if you are very much careful about the rules, they are valid identifiers. For example, let me ask you a little bit more questions. Just try to figure out if these are valid or invalid. For example, 3D point class, or for example Hollywood wine, or something like that, star dollar coffee, or something like public. So if I copy all these things, go back to my IDE and paste it over here and associate it, for example, with an int, let's say I'm declaring it as a variable, Alright, just to test it out, and let us give our statements. So you can see all of these are invalid identifiers. What is the reason? If you are going to find out the reason, then in this case the first statement, right, identifiers cannot begin with a number. So this is basically invalid. Second one, if you see this one, @ is not a letter, digit, dollar or something like that. So you cannot use @ as we saw in the particular rules. The third one is star is not a letter, digit, underscore or dollar, right? So star you cannot use. Star is invalid. And the fourth one is just a keyword, so you won't be able to use it. So make sure you guys pay attention. Okay. And the thing is, although you can do crazy things with identifier names, you shouldn't. Okay. Java has conventions so that code is readable and consistent. The consistency includes camel case or camel casing. So what happens in camel case is that each word begins with an uppercase letter. This makes multiple word variable names easy to read. So basically, if I give an example, which one is much more readable? This is my name or something like this, or this is my name. So this one is obviously more readable, and this is known as camel casing, right? All right. And the thing is, the exam will mostly use common conventions for identifiers, but not always. So when you see a non-standard identifier, be sure to check if it is legal, and if not, you get to mark the answer does not compile. Okay. And skip analyzing everything else in the question. That will save you a lot of time. Okay. And 1 or 2 or 3 questions actually come from this particular topic. They try to confuse you. All right. And some Java developers follow these conventions. I also follow these conventions regarding camel casing. So you can also follow these rules. These are really good if you want to follow. And if you see over here, method and variable names start with a small letter or small case, right? For example, int number of eggs. All right. And class names start with a capital letter. For example, my class or class my class. So these are some conventions that you can follow, but it is not mandatory, but it is a good practice to follow these things. Okay, so just you can play around with them. All right, so let us move forward to the next topic. I hope you guys understood a lot of things, and let us move forward to the next topic, that is local variables. All right, so a local variable is a variable defined within a method. Okay, local variables must be initialized before use. They do not have a default value and contain garbage data until initialized. Okay, that is very important. Please remember that. The compiler will not let you read an uninitialized value. For example, if I am going to create a method public int not valid, and so let's say int y equals to 10, int x, int reply equals to x plus y, something like that, and then return reply, right? This is a method. If you see over here, it doesn't compile. And why is that? Because y is initialized to 10 over here, that is fine. However, x is not initialized before it is used. So in this expression that you see over here, x is just declared, it is not initialized. So when you hover over here or you go over here, the local variable x may not be initialized. Until x is initialized a value, it cannot appear within an expression, and the compiler will gladly remind you of this rule. Okay, the compiler knows your code has control of what happens inside the method and can be expected to initialize values. All right, so the compiler knows everything. Okay, compiler is like a god over here. The compiler is smart enough to recognize variables that have been initialized after the declaration, okay, but before they are used. So for example, let us see another example, what I just said, public int valid, okay, and I'm just going to say int y equals to 10, int x, okay, x equals to 3, and then for example int reply equals to x plus y, and return reply. All right, something like this. And if you see over here, the compiler is smart enough to see that yes, it is valid. So basically the compiler is also smart enough to recognize initializations that are more complex. Okay, so let us see another example of how the compiler is smart, how it figures out that yes, it is a valid or it is invalid. Another example, okay, in this case it is valid because even though we declared it without a variable value, we initialized it again in this line. Let us see another example. Okay, so let us say public void and something like find answer, okay, and boolean check or something like that, right? And over here let's say int answer, okay, and these type of questions actually come in the exam, so make sure you actually pay attention. The actual thing is that the question may not be too tough or too hard to interpret, but the thing is you have so much less time that maybe you miss that thing, maybe you miss that question. Okay, so make sure you pay attention to it. So only one branch. All right, and let us say if check, okay, only one branch equals to 1, answer equals to 1, for example, and let's say else answer equals to 2, and then let's say sysout answer, and then for example only one branch. So if you see over here, it doesn't compile, and you may think that yes, it is fine, but it doesn't compile. Why? Because in here there are two branches of code. Okay, answer is initialized in both of them, so the compiler is perfectly happy, no issues with that. Only one branch that you see, this variable over here, is only initialized if check happens to be true, in this case over here, right? The compiler knows there is also a possibility for check to be false, resulting in uninitialized code. Okay, and it gives a compiler error. You will learn more about this if statement, else statement and everything in the subsequent chapters. We are going to discuss it in more details. Okay, so don't worry about that. Now so yeah, so this is how the exam may try to trick you. Okay, all right, so as we discussed about local variables, right, we saw a lot of scenarios where the exam might want to trick you and everything. Let's discuss something about instance and class variables. One second, let me just find out. Okay, let me just comment this thing out. Let's talk about instance and class variables, and let us see how it actually comes in the picture. Let me just remove this thing from here as of now. Okay, now variables that are not local variables are known as instance variables or class variables. Okay, simple as that. Instance variables are also called as fields. So another thing you need to understand, that class variables are actually shared across multiple objects. And how can you tell if it is a class variable? You can tell a variable is a class variable because it has the keyword static before it. You will learn more about this in the subsequent chapters about static and everything. But if, let's say for example, there is a variable called static int z equals to something for example 100, then this is a class variable and it is shared across multiple objects, and we are going to see how it is shared across multiple objects. But for now, just understand that this is known as a class variable. And this is, for example, int u equals to 100. This is known as an instance variable. Okay. Instance and class variables, right? These two things do not require you to initialize them. I just initialized, but it is not mandatory. Okay. As soon as you declare these variables, right, they are given a default value. You'll need to memorize everything that I'm going to show you in a table, except the default value of character or car. Okay. To make this easier, remember that the compiler doesn't know what value to use and so wants the simplest type it can give, that the value is null. Okay. So basically, let us see a table and you will understand what I mean. So this table actually shows everything. So basically what I just said is that for boolean it is false, for byte short, int and long it is 0, for float and double it is 0.0, and then for character you don't have to remember, but this is the thing, /u and 4 zeros in single quotations, and for all other things it is null. Any kind of other objects, if it is string, or if it is for example any kind of class variable like a reference variable or something like that, then it is automatically assigned a null. Very easy to remember. Okay. So yeah, that's all about default initialization values for class variables and instance variables. Okay, so keep that in mind when you are actually going into the exam, because going into the exam, if they can trick you by not initializing a class variable and also not initializing a local variable, and they will ask you which one is valid or something, and you can get confused in that scenario. So make sure you remember that class and instance variables are always initialized, even if you do not initialize them. They are initialized to a default type. All right. So yeah, so that's it for this lecture. Actually there is another portion remaining for this variables topic. I'm going to cover it in the next lecture as a part 2, because I don't want to make this video a very long one. Alright, so I'll meet you in the next video. Till then, bye bye.